So yeah, so my name's Miles. I'm an engineer by training, but I have accidentally gone down the route of science in the past, and they're two very different things, scientist and engineer, and I'll explain that in a moment. Obviously, that's just a bit of tongue in cheek. I have tremendous respect for scientists. I did when I started my when I finished my sixth form, my dad was a hydroelectrics engineer, so a civil engineer, but he specialized in dams, and they're called plate engineers. And my we didn't have a lot of money, but we were all right. We seemed quite comfortable, and I thought that's all I really wanted. I thought I want a secure career where I know I'm going to have a job for life and that I can sort of look after my family. And my dad was the sort of role model, I suppose, for that, or the benchmark. So I thought, well, I quite like building things. I had a load of construction kits and things when I was a kid. Makes sense that I become a civil engineer or a structural engineer. So I thought unequivocally that's what I want to do. At the um end of my third year, I knew unequivocally I never wanted to be a structural engineer. And that's why it's really, really hard for you to know what specialization you want to do potentially for the rest of your life when you're 16, 17. I mean, it's near impossible unless you've had extensive experience by some divine miracle of a particular area of engineering. It's very hard to know if that's going to suit you. You have to be able to experience things. And that's one of the key benefits of Cambridge is you get that general course for the first 2 years. So it lets you have a little slice of every bit of engineering. You do a bit of electrical, you do a bit of kind of materials, structural, you do some mechanical, you do some aerospace. You get a little slice of everything. So you can have the confidence of, you know what, I actually quite enjoyed that, or I find that quite inspiring. I'd like to learn a little bit more of that. And you can then start to specialize in your third and fourth year. People at Cambridge don't leave after 3 years. They stay for 4 years. That's the expectation. And that's you have to do that in order to get an accredited course because of the breadth of the first 2 years. So it wouldn't really warrant you being able to leave with a bachelor's in mechanical engineering because you've got that breadth. So if you're in for the first year, you're in for the fourth year. And we expect all those students. And as a result, the expectations, the requirements for you to continue to fourth year are, relative to the internal requirements at other universities, pretty forgiving here. Okay. So I was quite fortunate. I realized at the end of my third year that, I really wanted to focus in nuclear engineering. And in those days, Cambridge didn't do nuclear engineering. They do now, and I teach that master's course, or a lot of it. Um, and so I actually left and I went to Imperial for a year, studied nuclear there. It was a specialized course for kind of nuclear leaders of the future. There was only 9 of us on the course. Didn't go too well because 7 of them failed. So the university got in quite a lot. Well, the course director got quite a lot of trouble about that. But I went and worked for the Royal Navy. I was headhunted by the Ministry of Defence and then placed in the Royal Navy for 2.5 years working on nuclear submarines. Odd place to work, but it was Derby. It's probably the most landlocked place in Britain, so it's an odd place to design something that's supposed to be residing underwater. But there we go. And I kind of miss being a student a little bit. And we got the next set of next generation ballistic missile submarines approved. So I resigned and came back to Cambridge, um, and did my PhD here. And it was fully intended I'd go back to the Navy. But Cambridge is a bit of a bug. And once you're in, it's hard to leave. And so I was offered a lectureship and offered, a fellowship at this college and then an extra lecture. And I'm still here and I don't quite know how. But one of my favorite things is being a DOS. And Homerton, it takes a lot to decide what kind of college you're going to come to. And I was at Jesus before, but I've been at Fitzwilliam College. I've been at St. John's briefly. But Homerton Engineering is unique. And I don't have to say that. So I am being genuine with you that Homerton Engineering is a force to be reckoned with. And Scott's a good example of this that's going to talk to you later and give you a bit of a Q&A. And so I'm going to give you a little bit of insight as to why Homerton engineering is its own kind of force relative to just Homerton in general. But before that, we're going to talk a little bit about why you might want to study engineering. So I mentioned science versus engineering, or science and engineering is two separate things, and they really fundamentally are. Engineers develop new things by applying that science. So our objective is to solve real world problems by creating something new. Scientists investigate that which already exists. And if you don't believe me, then you can believe Albert Einstein, because he said it better than me, but it's quite hard to disagree with Albert Einstein. Having said that, I've got a nice story about when Albert Einstein designed a plane that the pilot said flew like a pregnant duck. So another example that scientists don't make necessarily good engineers. So if you like the idea of solving real world problems by developing something new, engineering is the thing for you. And as an admissions officer, I used to be an admissions tutor. I'm director of admissions for the engineering department. I would say if you like being creative with maths, that's a really key interest for you to excel in engineering. Maths is the biggest indicator of success on the engineering course. So you've got to at least enjoy to some extent doing maths. Otherwise, you might not enjoy being an engineer. Okay, so we've got lots of different specializations that you can do. You can have aerospace and aerothermal engineering. Jenny Sidney on the bottom right here was a peer of mine at Jesus College. She is now an astronaut, and she was in the reserve team for Artemis 2, Artemis space expedition that just went up. That's what being a Canadian gets you. And she's specialized in combustion, so she did a PhD with me. On the left is actually a student who was a professional skier who took the opportunity of his final year research projects. All the students get to do their own research project in their final year. And he chose to optimize his ski gear in the Markham Wind Tunnel, which is next to my old office. And it is incredibly loud and very annoying, but very good for the skier, apparently. So you could see him, he was always in there, just refining his equipment, leaning down and doing sort of different angles to try and optimize his aerodynamics. And it was actually quite a good project in the end. Electrical and electronic engineering, information and computing engineering, that's probably the kind of the fresh up and comer for the most popular specialization at the moment. And so a lot of the popular things are interfacing between computers and humans. So for example, a holographic keyboard or an invisible keyboard with a camera, and your camera looks at how your fingers move, and then we use machine learning to try and optimize. So because your hand will drift depending on how you're sitting. And so you need algorithms that will correct for that. So in theory, you could eventually get to the point where your webcam on your laptop is enough for you to just have a keyboard and you just tap on your legs or your table that you're sat at. You won't need a keyboard anymore. Personally, it doesn't really appeal to me, but there you go. Okay, so then we got our energy, sustainability, and the environment, civil, structural, and environmental engineering. So this is a student in the middle crawling through a reinforcement cage that is soon going to have concrete poured through it. So they are rebars, reinforcement bars. So you'll learn all about load distributions and how you calculate sort of bending moment and moments of area for reinforced concrete. That's one of the things that I teach or have taught in the past. Earthquake resistance. Then you got mechanical engineering, bioengineering. The steel processing there, that's Port Talbot. So that's a forging facility where they continuous cast and forge there. So that's a student that went on a trip over there. Superconductivity lab is run by a friend of mine. You can see a superconducting magnet there, or a superconductor with a permanent magnet that is causing type 2 superconductivity. So that's the fancy word for that is quantum locking. So a little bit on sort of superconducting trains. For example, you could do maglev trains as a research project. We'll jump that. So if you want to have a look at engineering at Cambridge, we are huge relative to other subjects. We're the biggest department in the university. We make up about 11% of the entire university in terms of human beings. That's 165 teaching staff, 320 postdocs, so people that have done their PhD and carry on doing research, 850 postgraduates, so those that have got their undergraduate degrees, 1,200 undergraduates in total. Okay, so you're looking at an admittance of about 330 or 300 each year. Right, we have at Homerton a fluctuating engineering community, but we have over the average over the last 5 years, we have been the largest engineering cohort. We've reduced our numbers ever so slightly in the last 2 years, but the aspiration is to go back to where we were before. We manage it depending on application level, but my aspiration is we have 20 to 25 engineers each year. And the reason why we do that is research suggests we're an academic institution, so we make decisions based on evidence and data and research. And that goes for educational processes as well. So evidence suggests that the larger your community of support, the more successful you are. And we've seen that at Homerton. So in the last 6 years, Homerton has completely transformed to become one of the highest achieving colleges in engineering. So we're far beyond, we're consistently in the top 3 in terms of academic attainment, despite the fact that we are one of the largest colleges, which normally is kind of inversely proportional. So we've kind of defied that, and it's because we follow a particular approach to education and community of engineers and the support that they give one another. You can't do an engineering degree by yourself. You have to do it with others. And having a peer next to you that you trust and support and you help one another is like having a supervisor with you permanently. And Homerton, I hope Scott agrees, and he's very welcome to disagree with me if he feels that way. Homerton has a very strong engineering community, and they are their own entity. If you're a Homertonian, but if you're an engineer, you're a Homerton engineer, and they're a bit notorious in a positive way in the department. For several years, we won every single competition, and then they had to change the rules, so one college just couldn't win every competition. So now they split the colleges amongst themselves in different teams and run different competitions. So unfortunately, I can't go to all the other DOSs and say Homerton gets the gold medals again. Right, so we've talked about that already. One of the most interesting things for students is that kind of opportunity to do independent research. And the integrated design project is your first real experience of that. So that might be that you're put in a team with other Homertonians or people from different colleges if they don't want Homerton to win it, and have the opportunity to develop a robot that might have a job of perhaps collecting boxes. It might be a robot that's going to run in a warehouse, and you've got to identify a box, see if it's the appropriate box that you're supposed to collect. The robot's going to have hardware that can allow it to pick up the box, travel with visual identification, and drop that box off where it's supposed to. And so you'll have a team where you'll have a team leader, you'll have someone that does the coding, someone maybe be committed to debugging, someone's dedicated to the hardware, maybe the visual versus the mechanical. So it's your first foray into a kind of design team, and you're supported by the department in doing that. Then you get to do some more projects in your 3rd year, one group project at least, and one design project to a similar vein. And then in your 4th year, you get to do your major project, which you can propose yourself in discussion and agreement with one of our academic staff, or you can pick one from the plentiful list that we afford to the undergrads. Okay. All your facilities at Cambridge are available in the engineering department. So we've got a computer lab. So if you ever need to use any software, you can use that. We've got a huge library for you to use. We've also got a specialized language unit. One of the opportunities that you have while you're here is to study a language that can contribute to your credits, to your degree. So a lot of students take up that opportunity, and they might learn something completely new, like Japanese, and you'll learn it from an engineering perspective. So you'll learn the vocabulary in Japanese for you to function reasonably well conversationally in Japanese. Or you can do sort of develop French. If you have a bit of French, you did GCSE French or an equivalent, you can start to expand your French and make that more advanced. German, Italian, Chinese, traditional Chinese, they're your options on top of Japanese and Spanish. And we organise trips and cultural activities alongside that to help you better learn your language. Best way to learn is to force yourself to speak it. So all of our courses are accredited. So if you specialise in a particular area, it will have accreditation, provided you go into you decide to stay for your fourth year. If you want to do your full 4 years, you have to do an industrial placement. You have to get work experience, and we help you to do that. Okay, so we've got a full-time dedicated industrial coordinator that helps students find industry places. And I will help guide you and go over your applications because actually it's quite a lot of cold emailing often, but you've got all that to come. It's not just work though. We did quite a lot of play. So again, a bit of superconductivity because people like the liquid nitrogen and the water vapor and all the mystery of that. But you can also join Formula Student, which Scott is a member of. That's right, isn't it, Scott? Because I've approved various financial applications for you.
Yep, that's right.
To go to Silverstone and things like that. So Scott will probably talk to you about that. So that's bottom right. So you get to build and race your own little race car. And I'm going to try and get you more money this year because I didn't realize you only had that $5,000 a year. So I'm going to fundraise for you. I reckon it won't be a problem. And then we can start using carbon fiber and things like that because I just can't believe
Thank you.
we haven't got that money. Top right is the Dyson Center, which is our make space. So you want to make something, we'll help you make it. So we've had students make all kinds of stuff. I had a student that I used to do sport with when I was PhD, became obsessed with making pens. He made pens out of all kinds of materials. So we have lathes, we have CNC machines, you name it, we've probably got it. And then we've got students that have made probably the grandest thing was a rowing boat, a full scale rowing boat. Now I'm not talking about competitive rowing like sculling. I'm talking boat that you can have a picnic in the 16th century with your I don't know family in it. And this chap made two of them out of wood, and it was so big that we had to take a section of the floor out. We've got a crane, 2-ton crane, and we winch and take that down and put it onto a lorry, and he took it off to whichever lake he was going to put these boats on. Maybe he sold them, I don't know, but they were very impressive. Okay, so there's lots of opportunities at Cambridge. We're seen as academically outstanding, and you get cutting edge, world leading lecturing and lab experience in engineering, but we want you to go further than that. So we want you to experience a broader range of activities at Cambridge. So we encourage you, at least at Homerton, to do extracurricular activities. Again, reason why is statistically students that do things like regular committed sport, or in particular choristers, oddly enough, tend to do academically achieve higher academically than those that don't. So although you might think, oh, playing football on a Sunday takes up a bit of time that I could be revising, statistically it's the opposite. It's that reset. So we encourage that at Homerton. Okay, so I won't go through this in too much detail because Alex has gone through all the sort of conditions of how to apply and the dates, and all of this is available online. So if you ever have any issues, I run the website for the engineering department, and I know it's all there because I put it together. Although it may be a bit labyrinthian for you. The key thing that we mentioned was the ESAT and interviews. So the ESAT is the Engineering Science and Admissions Test. Engineering Science and Admissions Test. So scientists take that as well. So if you want to do natural sciences at Cambridge, you have to do the ESAT. If you want to do engineering, you've got to do the ESAT. And that's a big part of how we assess applicants for engineering. So it is a very good idea for you to get a bit of experience of the ESAT. So you can, if you Google Cambridge ESAT, because Imperial now use it, and after about 4 years of me nagging my Oxford counterpart, they finally conceded that my test is better than theirs. And so Oxford now use the ESAT. So there's lots of universities jumping onto this. If you want to apply to one of those universities, Manchester and Bristol are also about to use it, then it's worth going on the website and having a look at the specification. And the specification details absolutely everything. that you could possibly be asked within this test. What you can do is you can go to your teacher and say, I've got to do this test. This is what we need. I need to know to do the test. Can I just make sure we'll have covered all of this before I do the test? Now, unfortunately, most of it's actually GCSE. Okay. So, particularly the maths. So, actually, you'll have covered most of it anyway. But it will be the hardest exam you have ever taken. The average mark is 50%, as it should be. That's what every exam should have, is a mean mark of 50%. I'm the one that oversees this. It's produced by Pearson VUE, which is an examination board. So you need to obviously get above average, but I can't give you what's the typical score of a successful applicant, because all of you are individual. Okay, so we look at you holistically. So interviews are the other aspect. So interviews it's easier said than done, but you need to just see it as another day at school. Okay, you've done all the hard work. You've done all the hard work. Now it's just another day where you're going to be answering very similar questions to what you will have seen in the ESAT, an interview context. And it's really because I just want to hear what you're thinking. I want to hear how your brain works. That's what we're trying to assess in the interview. It's another opportunity for us to validate or cover any gaps we've got in assessing your paper application. So they're going to be technical questions. Normally get 2 to 3 technical questions. Predominantly it's mechanics. You tend to see across the colleges, and there's various videos, and I've got some videos online of what to expect in an interview. So I encourage you to look at those. The key thing is what we want to see is your academic potential. Okay. And a lot of us haven't had the opportunity to fulfill our academic potential because of our personal circumstances. You might be a carer for someone, for example. So you haven't had the opportunity to go really beyond the scope of your curriculum at school and investigate additional things, or read magazines about engineering and things like that, or even industrial placements. Some people do work experience. Some people haven't got the opportunity. But what we want to do is we'll identify what scenario, what situation you're in, and we'll examine you relative to your circumstances. And the key thing is that in your situation, you present to us your level of understanding of the stuff that you've studied to date. So I don't want to know if you can just regurgitate equations. I want to see if you actually understand that stuff. So the questions I'm going to ask you in the interview are conceptual questions. I'm not going to say, differentiate this, integrate this, put those two together to find this. I'm just going to say, here's a problem. How could you solve it? And it's up to you to figure out, well, okay, what I could do is I could differentiate it, then integrate it. You know, the method is the same, but actually you have to understand the reasoning why you differentiate or integrate something in order to actually interpret its usefulness. And that's what I'm assessing. I give you a scenario. I know you know the methods to do it. It's whether or not you can piece those together to plan how you're going to solve that question. Okay. I will teach you something new. So I will say, right, have you ever studied circular motion or something like this, or you know, conservation of angular momentum? And you go, no, I don't know what that word means. I go, okay, and I'll teach it to you. And then I'll give you a new scenario and I'll say, apply what I've just taught you to this new scenario. And that helps me see how effectively you can absorb new information and engage it, albeit in a pressured time situation. Okay, so I'm aware that people react differently in those kind of circumstances. So I account for that. Okay. Right. Again, all of this is available online. There is a YouTube video. If you type in Homerton Open Day, a lot of the information is the same with how I approach interviews at Homerton. So all of this is available online on YouTube. So don't panic if you go, I missed that. I want to see that again. There's recordings online, and maybe Alex, they're getting a recording of this. I don't know. Good. Okay. So a big thing that people worry about is how to prepare for the interview. Just do well in school. Just keep doing your schoolwork. Have a look at I want to study engineering.org. It's I-1 hyphen in between the words. I want to study engineering.org. And that's a treasure trove of interview style questions. They were actually the interview questions we asked. And then the head of the department decided it'd be a great idea to put them online, which took away the whole bank of questions that everyone was using. So now they're all online. So we don't ask exactly those questions anymore. But so they're very similar to the sort of things that you should expect upon a interview. I don't really like that top thing, and I constantly need to delete that. The important thing is not to be too anxious. I mean, well, thanks, great. You can't really help being anxious, so that's absolutely useless information. We're all anxious, and some of us are more so than others, and we understand that as an interviewer. I'm aware of that, and I can see that in individuals. Much as I don't know you, I can see that, and I will account for that. So the priority is just try and limit it. So just dress comfortably. I don't care if you're in a suit or a onesie. It doesn't really make sense if you were to be in a onesie, but I wouldn't judge you. So just be as comfortable as you can be. It'll help. I suggest what we could talk is I'll do a little quick brief overview on what it's like to study engineering at Homerton specifically, and then where are we with Alex? When are we supposed to finish this? Because we got the Q&A, and normally that always takes longer than we expect.
Yeah, so if we maybe do like a 15-minute session here and then move over
Okay,
to the Q&A for half an hour.
fine. Okay, so I've got 15 minutes. Right. Okay, so engineering at Homerton. Your college, regardless of what college you go to the same lectures, you do the same labs. The difference is, well, there's several differences. One is that the college is your home. Okay, it's where you live. It is where you eat normally. They provide you various different facilities, and college facilities are different. Some colleges are right in the center of Cambridge. They can feel quite busy, a little bit smaller, a little bit bigger. People, they're different architecture, and often they have different feelings to them. One of the most common questions I get is, how do I know what college to apply to? Again, it's a bit like, what specialization should I go into? Try and get as much experience as possible of each one. So the open day is in the first Thursday and Friday of July. I think that's the 6th and the 7th. No, it's not. It's the 9th and the 10th. So 9th and 10th of July, you can come to the department, experience a bit of the department. You can also go to the colleges. Oh, we got a very vocal bird in my. I'm outside a building site actually. So I would suggest you go to the open days, experience some colleges. Definitely come to Homerton, have a look at it, see if it fits you. I think Homerton is a particularly friendly college, especially the engineers. And the difference at Homerton is the supervisors that you get. So each college selects their own supervisors, and you have normally, let's say, 3 to 4 hours a week with that are kind of groups of 2 or 3 with one academic who's a specialist in that area that can help you to better understand the content that you've covered in the last 2 weeks in that particular module. So I might supervise you for mechanics, and you'll have studied for about 2 weeks. You'll have a little problem sheet that's been set to you. We'll go through the problem sheet. You'll have some issues there. I haven't got a clue what D'Alembert's force is, and I'll explain what a D'Alembert's force is and how that relates to what the expectations are of you in your exams and beyond. So that kind of comes in the afternoon. So the morning is dedicated to the department. It's your labs and your lectures. In the afternoon, it's private study, where you're supposed to go over your content from the lectures and the problem sheet. So then you've got supervisions. That's what I was talking about before. And then now and again, you'll have a drawing class or a lab that'll extend into the afternoon. So typically, an engineer at Cambridge, there was a survey done, it must be about 10 years now, by Which magazine. You might have seen adverts, Which magazine voted the best washing machine. Well, oddly enough, they did a university survey, and it was found that engineers at Cambridge have the highest work hours of any degree program in the country, despite what the medics might say to you. And I think that was about 42 hours a week, on average, 42 to 46 hours a week they were taking. Right. Okay. So the other thing about Homerton is the opportunities for additional sort of super curricular learning. So what we try and do at Homerton is we try to encourage mentorship programs. So what we normally do towards the end of each year is we assemble our alumni. We try and ensure that we've got engineers from across the broad range of industries to offer their services in mentoring our students. So they can help you write CVs, they can help you write cover letters, they can guide you in sort of keeping a finger on the pulse in the industry. You have me as a director of studies, and my responsibilities are to oversee your academic progress. So if you've got any academic problems, then you come to me and I'll give you some advice to help you with revision strategies, study strategies, what kind of projects to pick for your final year, maybe certain projects that you might want to avoid, things like that. And then you also have your personal tutor who's dedicated to your college. Their responsibility is pastoral. So that means well-being and welfare. Okay, so I don't work with you on sort of what I would see as kind of personal issues, unless they're academic. You go to your tutor about that. We keep me distant to that for you. And again, Homerton has facilities that are available to you, like the library, computing facilities, a gym, choir, all kinds of things. And then we got the engineering society. So it fluctuates in how active they are per year, but tends to be Homerton is pretty active. They arrange sort of swaps, as they call. So they're like social nights with other groups. It might be a sports team, or it might be other college engineers, or it might be another subject at the college or a different college. We do curry nights where I'll take all of the engineers out for a curry, and that's quite a good night. We did that a couple of months ago. I can't quite remember how long that ago was, but Scott was there. We do celebratory punting after exams. So I try to coordinate it so the older years will pick up the first years when they finish their final exam, pick them up in a punt. I don't go with you because I don't want to see what happens. And we set you off in your boat off on the river, and you have a good time there. And hopefully you get the boats back in time. Otherwise, I get a hefty fine. We do competitions, force professors to summarize their research in 3 minutes, things like that. So it's really quite a strong community of engineers at Homerton. We used to have an engineer's boat as well. So a whole rowing boat that used to enter the university competitions that were just made of Homerton engineers. But we haven't done that in a couple of years. And we did have a band, an engineer band. It wasn't called the engineers band. That would be too embarrassing. I can't remember what they were called. But my most important is the cardboard boat race. And I'm always disappointed if this doesn't happen or we don't enter it. And it's a competition at Cambridge where you've got to build a boat out of cardboard and see how long it lasts. It is a race, but then so cardboard boat race, that's what you want to commit to. If you're going to get anything from engineering degree, one aspect is getting the degree certificate at the end, and the other is winning the cardboard boat race. Okay. If you don't win the cardboard boat race, I won't disown you as a director of studies. I'll just be very disappointed. So this is an example of one of my finest teams. Unfortunately, it wasn't Homerton. It was when I was at Jesus, but these were the Jesuit engineers that I oversaw building their dragon boat. When I'd just become a DOS. It was about 10 years ago, something like that. And that was remarkably efficient. They were a bit naughty because they used wood as their oars, but it turns out everyone cheats with the oars. So there we go. And I did try and get them to breathe fire out of it, but then I realized the risk assessment probably wouldn't pass. Good. Okay, so that's kind of engineering at Homerton. So these are some one of my first year of Homerton engineers that graduated together. So that's Homerton engineering. I think it's probably now time for our Q&A, is it not? If you want to learn more, these are probably the most appropriate links for you. But we'll do a little Q&A. What's the best way to catch up with A-level further maths to prepare? Okay, if you haven't done further maths because you realised too late or your school didn't offer it, say so. Say so in your application and try and just do as much maths as possible. It's the best way to prepare for the ESAT and the best way to prepare for your interview and your time at Cambridge. There's something called the Advanced Maths Program, AMP. If you Google Advanced Maths Program, it's free. So there's loads of free resources that you can study further maths and do additional maths yourself. So I would just do that. Just do loads and loads of maths. And there's so much out there of extra questions and things like that. That's what you do. Advanced maths program. Give it a go. Right. Hi, Scott. Have you got any tips to revise the ESAT?
Hi, Miles. No. So just to give some background, as a second year student studying engineering, I was actually the last cohort to sit the previous exam, which was called ENGAR. But fundamentally, it was a very similar exam, very similar difficulty. And I think what really helped me when I was studying for it was obviously there are past papers online. I believe there's example material on, I think there's an ESAT website. But in addition to that, there are several people who just go on YouTube and they'll go and decompose an entire paper. They'll explain exactly every single step of every single problem in a paper. They'll give kind of extra reading that you can do. They'll recommend other videos that you can watch to extend your understanding. So probably those YouTube videos helped me most when I was preparing for the equivalent admissions test. But kind of like what Miles said earlier,
Yeah, there is. Yeah.
just like, oh, just like what Miles said earlier, having a really, really solid foundation in both maths and physics. And just to stress, it is only regular maths, I believe, in the ESAT, which is examined, because some students applying to Cambridge won't have completed further maths, and that'll be the same for Imperial and all other unis taking it. So just having a really strong grasp of maths and physics at A level should prepare you and put in the groundwork as well.
Yeah, my advice in terms of preparing for the ESAT is go on the UAT UK. Just Google ESAT exam, and it will take you to the UAT UK, University Admissions Test UK. It's a joint venture that we started to run this test outside of Cambridge. And have a look at the sample. So there's a sample exams. There's the past exams of the ENGA. The ENGA and the ESAT are almost identical, except with a slight bit of difference to timing, but the content is it's exactly the same. So now you do maths 1, maths 2, and physics. Before it was physics, maths, and advanced maths and physics. Now it's a misnomer. It's not appropriately named because it wasn't advanced. It was just more of it. So that's why I changed the name to maths 1 and maths 2. But you can use past papers. I would have a look at the specification. And really, you only need to do like 2 or 3 past papers. That'll be sufficient for you. But do them in time conditions, because you will notice that the timing is a real factor. So at least you have to do one timed one before you approach the real exam. But that's standard for every exam. So be quite firm with yourself about your timing. The first time you do it, you will lag behind. You've just got to gain a bit of experience of how quickly you need to do those questions. Okay, I'm interested in design engineering, like product design. Would engineering at Cambridge prepare me for that? Yes, actually, when you apply, you'll be doing, well, it depends on when you're going to apply, but if you're coming in 2027 onwards, you are going to do a revised tripos. That means that a revised course syllabus where design is becoming more dominant. So we do design at the moment in sort of structural and materials engineering, but it's actually going to be its own module, its own paper now, design engineering. So we do a lot of design, but it is going to grow, and we are going to focus a little bit more on the principles of design engineering. So looking at how you start at a specification and you develop from preliminary, concept, detailed testing, and aspects like that. And quite a lot of people do that in manufacturing engineering, which is a branch off in you can move in your 3rd and 4th year into MET, manufacturing engineering technology, and that's a bit more business, the business side and economic side of engineering.
Not to take away potential applicants from you, but there is also a design course as well. So if you are particularly interested in design, it's worthwhile having a look at the entry requirements and specification for the course itself, which is a 4-year integrated master's as well. And I believe, somewhat related to the engineering faculty, with it being with the faculty for architecture right
Yeah, yeah,
by.
yeah. It's principally an architectural course. So
Yes.
we've had very little engineering
Okay.
departments had little to do with it, which was somewhat infuriating, I'll be honest.
Right.
But yeah, that you do stuff like you do some structural engineering, you'll do some product design along the same kind of guys with computer aided design as we would do in engineering, but it is predominantly architecture.
Mm.
So you are doing a sort of architectural focused design program, but it's very popular. And it's the students speak very positively about the program. So yeah, if you're so inclined to that, then I would have a look at that.
Cheers.
Okay. Once I've finished the available past papers for the ESAT, ENGA, and NSAA, how would you recommend preparing? I mean, it's not really much you can do beyond that, is there? I mean, like I said, you just do well in your schoolwork, and you only need to do a few papers. I never expect anyone to do all the available past papers. That's, I would say that is certainly excessive, because eventually you get to the point where you're not really gaining anything. The main thing about doing the past papers is getting used to the structure of the exam. Yeah. Getting used to the structure of the exam and the kind of conceptual questions. Like I said, the content is the same as you've done at school. It's just instead of telling you part A is do this, part B is do this, part C, we just say, here's the problem, and you've got to identify what you've got to do for part A, part B, part C. So I think you've done plenty there. I don't think there's any more that you would need to do. Okay, when I've looked for example timetables in the engineering department website, a reasonable amount of time is spent in lab. What does this consist of? And can you give examples? I think Scott is probably the best place to answer this one. So what does it mean to be in a lab, and how often are you in there?
Well, firstly, what I'd say is the timetable on the engineering department website will have a lot of lab slots, but that doesn't necessarily mean you'll have a lab at that time. So everyone, when they get into when you start at Cambridge, within the first week, effectively, you'll be given a lab group number. You'll be buddied up with one person, and you will firm it out for the whole year, basically, through quite a few labs. Typically in first year, there are a couple of labs per week. It will be there's actually nothing riding on them. It's a very, very nice system. You get to apply your theory into a practical and relevant task, but you're not actually assessed on it other than turning up and putting in a kind of qualifying effort. So there's something called standard credit, which basically means if you turn up to the lab and do as you're told, you will just get the qualifying mark, which is effectively 100%. In the labs, it can vary massively. Sometimes you'll have a short lab. It will be 2 hours. It's basically turn up, you get given a sheet with some instructions, play or use some apparatus, get some reading, some results. But it's just to kind of get a grasp of a physical application of what you will have learned in lectures. The next step up is a long lab, so that will still be 2 hours. You're still using apparatus. You're still applying theory to a practical task. But afterwards, you'll then write a lab report. The lab reports take a bit longer. You're given extra marks because the lab reports do take some time. And you'll have a couple of those per term. I think in first year, it's maybe 3 per term. So 3 long labs, maybe 4 or 5 short labs. But then also running through almost every single term at Cambridge, there are very, very long projects. So in first year, you'll do something called structural design projects. You'll design effectively a bridge or something called a truss, which is it's like a triangle sticking out of a wall. But the idea is that you're trying to apply your structural design theory to an actual application. And you don't just use apparatus in that case, you actually design something. So we designed a truss, other teams designed a bridge. It's a really fun event, actually, because you get to do it for a whole half of a term. And you get to test it with your friends afterwards. It has to hold about 200 kilograms. So it's not some kind of silly little thing. It's actually quite a substantial product that you make. And that actually carries on into second year. So I think the highlight of second year for a lot of people is the integrated design project. you're put into teams of 6 and you make a robot. So Miles mentioned earlier a warehouse delivery robot. You do actually make an autonomous warehouse delivery robot. And you're not guided very much, which is very nice. You're given a lot of autonomy in labs. A point to note is that lab does dominate the term. You end up doing almost 8 hours a week, I believe, for that lab, whereas the majority of the time at Cambridge, you'll maybe spending on average 2 to 4 hours of lab time per week. But yeah, hopefully that's given a bit of a sporadic overview of what you can expect.
Good, yeah, thanks for that. Okay, so how much time in a week would an engineering student spend on clubs and societies? What do you reckon?
It depends on how much. It depends on how much time you spend on other things, I guess. I myself, I'm part of both the university's Formula Student team, so we make a race car every year, and the Spaceflight Society. And between the two of them, I'd say it might be about 6 hours per week on kind of an average week. It doesn't really deviate that much though. But no one has to do a society. No one has to be constrained to a certain time. If you love your society and all of your friends are in that society and you have a great time working there. I know some people that will put maybe even 15 hours in per week, and it's kind of their passion. Whereas there are other people, they just turn up once every few weeks. They'll be there for an hour, and with these societies, there's no entry process, there's no application process, there's no skill level desired. It's just basically, can you contribute and can you be a team player? So there's neither any constraint nor expectation on the time you'll spend in any society at Cambridge, whether that's engineering or otherwise.
Good. Yeah, I agree. Okay, how early should I start preparing for the ESET if I was sitting in October? The summer, you can use the summer. That's reasonable. So when you finish school and you get your summer break, I would start looking at it then, because you've got to apply. You just make sure you check the deadlines, because normally the deadline is September 1st standard. But if you need access arrangements, so you get extra time, or you need larger print or anything like that, then you've got to apply earlier. So be careful. Make sure you check the website for dates. But you've got the summer to focus on doing a bit of ESAT while you're having a break. Again, I can't answer what the typical kind of mark to get during doing your tests of the ESAT. It's very hard. It's individual to you. So that would be a kind of hour-long talk for me to explain how you could assess that. Right, Scott, what made you pick Homerton?
Miles made me pick Homerton. So actually, out of those two options, I got in through a third way. And in fact, there's a fourth way that you can get into a Cambridge college. So I actually got in through something called the winter pool. Typically, I think 20% of successful applicants to Cambridge get in through the winter pool. And the winter pool is basically, it's called the winter pool because it happens in winter. In fact, it happened underneath my accommodation this year. It's quite exciting to see everyone sat around the table getting it all sorted out. But everyone will apply in September, October, etc. They'll go through the whole application process. Some people will achieve a good enough admissions test score or have a strong enough application to be taken in for interview. And after the interview over Christmas, decisions will be made whether to accept someone, to reject someone, or to basically say, look, we don't have enough space. We've already accepted as many people as we want, but we still think this person would, do well at Cambridge, which is, I guess, the situation I was in. And then, yeah, I think there's a bit of a discussion, and you can be fished out of this pool. So if you're in the pool, there's no guarantee you're going to be fished out of it. But it means that you're you're still at the same standard.
Yeah, it's a place, so colleges fluctuate in the number of applicants they get. So Homerton has normally been in the top 3 in terms of total number of applicants over the last sort of 4 or 5 years. But it fluctuates from year to year. And so certain colleges have only a certain capacity. So you might have more applicants that you think are capable of studying at Cambridge, you have space for. So you put them in the pool. And then colleges that, want to have more students than perhaps have applied to them, or want to kind of see if there's potentially more appropriate students for that college in the pool, will have a look in the pool. So I always actively use the pool because there are always outstanding applicants in the pool, because a college can't take someone because of various different scenarios that may mean that they've reached their capacity of a certain sort of student. And there we go. Okay, how many people swap courses between engineering and natural sciences? It's very, very few. Very, very few. We're talking, none every year, or at most one, really. And that's for kind of each college. Yeah. So the majority of cases, we don't have anyone swapping within Homerton, and there's very few across the department that exchange. Most exchanges will happen at the very start of the year, and it's in really exceptional circumstances. So you will have to be assessed relative to the peers in the subject to which you're going. So normally I would call for a student to have another interview with me. I would interview them as I had done other students, and I would assess their academic potential as I have with others, considering the capacity that I've got and quality of my students I already have. So that's tricky. Deciding between one and the other, that's why you kind of really should try and do this now. The best thing to do that is gain as much experience in what it is to study science versus what it is to study engineering. So it's read New Scientist, read magazines, look in blogs, go on, if it's aeronautical, on the Royal Aeronautical Society, and have a read of their news and see what sparks your interest. If you're more inclined to the science rather than the engineering, it indicates perhaps sciences is for you. If you get an opportunity to, shadow an engineer or shadow a scientist, that's a really unique opportunity. Do that. Have a look at videos online that are by sort of Cambridge admissions and things like that, to get a little bit of a taster for what it's like to be an engineer or to be a scientist. You've got to expose yourself as much as possible to both areas and see which one sort of fits with you. And sometimes both are suitable, and it's just kind of going on how you feel about it at that time. Okay. What type of engineering are you going to specialize in, Scott?
Okay, so this is probably a wider question than it sounds, because Cambridge engineering just isn't as simple as saying I'm going to specialize in like aeronautical engineering, or I'm going to specialize in control systems, or I'm going to specialize in structural engineering, etc. Because our third and fourth years are extremely modular. So my plan next year, I mean, it's neither here nor there. My plan next year is probably majority aero modules. And then I'll also kind of bolster it up with some biology modules, so bioengineering, and a few mechanical engineering modules. But really, some modules will mean that you can't take other ones, or you can't take other ones very easily. But there's like basically a plethora of modules that you can pick from. I can't remember the exact number. I think if it's not 100, it's very close. But yeah, you will be spoiled for choice, and it won't just be, I want to do aerospace engineering. It'll be what's parts of aerospace engineering have you enjoyed? And if there's a part of aerospace engineering you haven't enjoyed, then you can go, okay, what specific niche of mechanical engineering have I enjoyed? So really lots to look at in third year, and the first 2 years really prepare you for that, because you do such a broad range of modules in your first 2 years, which are compulsory. You're very exposed to a taster for all of those third and fourth year modules.
Good. How does individual startup support funding comparing Cambridge versus Imperial? Well, colleges have their own startup funding in some cases, in most cases. And often the same organizations and institutes that come in to try and encourage these startups go to both universities, because they know there's potential at both. So I'd say kind of Cambridge marginally has more because the colleges have more money, so they can put more money into encouraging entrepreneurial endeavors from a college level, and that is actually growing in popularity. So in the next few years, I think you'll see a bit more dominance of entrepreneurship. So Changemakers, for example, is one program that is supposed to encourage entrepreneurship at the college, and they have seed funding and a competition for you to obtain seed funding for your program. And we've had several very successful teams go on and start companies from that seed funding. Judging the interaction so far, I'd assume that faculty-student relationships are great and help is always around.
Yep.
No, I have bribed Scott
Oh,
to
yes.
feign enjoyment and appreciation. He's actually normally miserable and terrified of me. No, yeah, I think we're quite good. I think it's all about mutual respect. This is a professional environment. It isn't school. So I expect students to be cordial and respectful to staff and one another, and behave in a professional manner. So I treat students with a mature adult approach as though I would with my own staff. I'm very happy to support my staff, and I'm particularly happy to support my students because that's what I'm contractually obligated to do, but I would do voluntarily anyway. So yes, I think we've got a very, very good relationships between staff and students. And if you ever need help, there are so many signposts and so many people there that are employed to assist you, from your personal tutor to your DOS to your senior tutor. There's many opportunities there. So yeah, absolutely. And that's something that's particularly unique to Cambridge, is that abundance of support that you have around you, that a lot of you asking about Imperial, you just don't have other universities that aren't collegiate like that, with this significant endowment that can afford to pay for these things. Would an engineering student typically have enough time to take part in sports clubs, and does Homerton offer girls' sports? Yes, they do. And yes, you definitely. And I would actively encourage you to take part in sports and other non-sporting activities. And yes, there are girls' teams. There are very successful girls' teams. There is a mixed football team at Homerton. I think the Fourths are the mixed football team. But there is a girls' football team that has been highly successful. I used to coach the girls' football team at Jesus, but my days of doing that are long gone. I was a football captain when I was a student, and the oldest football cup in the world is the FA Cup, Football Association Cup in the UK. The second oldest cup is the Cambridge University Football Cuppers Cup. So I can say that I've won the second oldest football cup in the world. You could argue it's the oldest, but it wasn't formally recognised until after the FA, because the rules of football were kind of formalised at Cambridge. Obviously, football goes way back to that, but the formal rules that are the basis for modern rules of the game were developed at Cambridge. Right, last two, so I thought we might as well just finish them. I've been reading a few books from the recommended reading list, really enjoying them. They're strongly focused on broad philosophical overviews of engineering mind. I'd like to see some more technical analysis of engineering problems. Are there any resources you suggest for a more in-depth exploration of a topic? God, how long's a piece of string? Yeah, there are lots of books that kind of meets all possible considerations. So it depends on what your specialized topic is. And actually, Google is a remarkably good friend at giving you, if you tell Google exactly what you want, it'll spit out a pretty good book. If you want to do aeronautics, then you can have a little look at, for example, the Cambridge University Library. We have a search function, because actually Cambridge University Library is available to the public, and can show you some of the most sort of popular books that we get out, and some are a bit more basic guides of design of aeroplanes or ships and things like this. So it might be a little bit more technical and give you bit more of a challenging read. I think the recommended reading list is probably most appropriate for trying to inspire you and getting broader experience of engineering. But if you want technical, you've got to look into a bit more specific. Yeah, so that's a bit more of a digging.
But also,
if you have a top, go on.
Absolutely, if you want some technical experience, and if you're not particularly dead set on going into academia, I would also recommend doing a project. If you've read umpteen books so far and you've thought, wow, this is really interesting, try and start applying it, because that is really what will make you stand out when you go into well, it's not the thing that will make you stand out, but it's just another thing that you can show at an interview or in your application that really demonstrates that you want to be an engineer. I think I remember when I was in sixth form, potentially a few people made the mistake of overly getting into just reading and kind of forgetting why they were applying for the course that they were applying for. But if you're really passionate about engineering, I'd say, yeah, get involved with either some work experience where you will learn a lot of technical knowledge, or make something. It'll be fun.
Yeah, it's a good idea to get a bit of experience by doing your own kind of research project. And a lot of literature is publicly available. It's open access. So you can go on Google Scholar and you can search for papers, and you can specifically say open access, and you can look for technical papers in a certain area. And then that might give you some inspiration for what you might want to do on a research project. And then you could look at doing your own research project. I've done research projects with kind of sixth form high school students, where we've done things like develop a body worn system that identifies the onset of heat stroke, because there were huge death rates of construction workers in Kuwait, and in particular Qatar, during the construction of the World Cup stadiums. And the main problem is they don't have the appropriate legislation, but we developed a prototype that initial testing showed that it could actually be quite successful in mitigating deaths from heat stroke. And that was a sixth form student that was messing around with an Arduino. So that's the kind of thing you could do. What is the pass progression rate for engineering course? 99% and above. So engineering actually has one of the lowest failure rates. It's normally about 0.5%, 0.5 to 1% across the university is about 99%, and engineering is lower than that. So most people pass. Right, last one. What does employability look like for fields such as finance, etc.? Yeah, as much as it debilitates me somewhat that I've just spent 4 years trying to teach how to be an engineer, and then you want to go and be a management consultant or a financier. The recruitment, the employability is very, very high. So you get lots of students that at least dip their feet in finance and things like management consultancy and other fields, because what you've got as a Cambridge engineer is you've got a good technical and sort of malleable mind with a very good work ethic, and you've got some strong math skills there. So finance is an entirely manageable industry to go into afterwards. Good. Okay. Well, thank you everyone for coming. I hope it's been useful. You can always reach out to the admissions office if you've got any further questions. Otherwise, hopefully I might see some of you at the open days in July. I'll be giving talks in the department. You can see some technical talks by some other professors in the department as well. And hopefully we'll see you at Homerton. So good luck with your application, and nice to virtually meet you all.